Okay, today's lesson is on the discriminant, which is part of the quadratic formula, so it's kind of what we did yesterday, a little bit different. The discriminant is b squared minus 4ac. The discriminant is b squared minus 4ac. Did you remember seeing that yesterday? Where was that? Under the square root, okay? It's what's under the square root. So for this first one, it says find the discriminant, okay? So it says find the discriminant. The discriminant is just this part. So I've got my A, B, and C. Got my A, B, and C. So what is my B value? -7. So -7 squared. Remember, you have to use parentheses unless you're going to remember to make it positive, okay? -7 squared minus 4 times, what's my A? 6, and my C? 3, okay? And remember, you may type all that in your calculator. Remember, you need to use parentheses, -7 squared, and then you have to use the minus button. That was some problems people were having yesterday. You have to use the minus, not the negative. Minus 4 times 6 times 3, okay? And you get -23, okay? -23. Questions? Okay, so here's the whole point of this. If your discriminant is less than 0, for instance, the one we just did, was that less than 0? How do I know it's less than 0? It's negative. You will get 2 imaginary roots, okay? Because it's negative and it's underneath the square root. What do you have to do when there's a negative underneath the square root? Pop out a I, and I stands for imaginary. So whenever the discriminant is less than 0, that means it's negative. That means it's negative. You're going to get 2 imaginary roots. Sometimes they call them complex. Okay, so that's another word to write down. Complex numbers and imaginary numbers are pretty much the same thing. There's a little bit of difference, but not that you need to know for this particular class. Okay, so imaginary and complex both mean that they're going to have an I in them. Okay, all right, let's see what the graph looks like for that. What's the other word for roots? X-intercepts, okay? The other word for roots is x-intercepts. So if I have 2 imaginary x-intercepts, do you think it's going to actually cross the x? No. So it might look something like this, all right? It could be in any of the quadrants. It doesn't matter. Does that parabola cross the x-axis? No. It doesn't have any x-intercepts. They are imaginary, okay? They don't really exist. So it would not cross the x. If you put it in your calculator, you'd get something that didn't cross the x, okay? All right, if the discriminant is equal to 0, if the discriminant is equal to 0, so if I have something like this, 5 plus or minus the square root of 0 over 5. So if I get 0 here, what's the square root of 0? What's 5 plus 0? What's 5 minus 0? For this one, you get 1 real root, okay? You only get 1 answer. This is the case where you get 1 answer. And we just talked about why. 5 plus 0 is 5. 5 minus 0 is 5. You're going to get the same answer. So there's only one of them, okay? What do you think the graph looks like for this one? Good, it hits at one spot. So you can draw it anywhere you want, but it's only going to hit at one spot. It's only going to hit at one spot. Questions? Okay. If the discriminant is greater than 0, what do I mean by that? It's positive. Okay. If it is positive and a perfect square, okay? if it's positive and a perfect square. So remember, by perfect square, I mean things like this. If I do the square root of 4, does that work out perfectly?
Yes.
Yes. Okay, square root of 9, does that work out perfectly? Okay. What about 5? Is this one perfect? No, that one's not perfect. Okay, so it has to be one of our perfect numbers. 4, 9, 16. Okay, so if it's a perfect square, you're going to get, bless you, you're going to get 2 real rational roots. Remember, we talked about that the other day. To be rational, it has to be a perfect square. If it has a square root with it, which the quadratic formula does. Okay, so it has to be a perfect square to give you rational numbers. Okay, all right. So, for example, let's say it crosses at 3 and negative 1.5. Are both of those rational numbers? Yes. Okay, both of those are rational numbers. So it crosses at 2 places and it gives you rational numbers. And I'm just making up numbers right there. Okay. All right, and the last case scenario, it's still greater than 0, so it's still positive, but it's not perfect square. All right, it's not a perfect square. Give me a number that's not a perfect square. The square root of 40, yep. Square root of 8, good. Okay, those are not perfect squares. This is going to give you 2 real, not rational, but irrational roots. Okay? So we'll say it crosses at the square root of 5 and negative square root 5. And I'm going to make this one open down just because I want to, but it doesn't matter. Okay? So that one crosses at irrational. Okay? So negative square root of 5, square root of 5. So those are irrational x-intercepts. Okay? Feel good? Okay. Match each quadratic equation with the nature of its roots. So we have 4 examples right here, and we have 4 answer choices in the box. Okay, so this one's matching. So you could do the whole quadratic formula that we did yesterday. Or what I'm trying to show you is you could do the shortcut. The shortcut is to do the discriminant. Okay, the discriminant. That's what we just talked about here. What is the discriminant? Okay, b squared minus 4ac. So b squared minus 4ac. Okay. So I have my a, b, and c. Okay, so let's plug that in. So what is b? Negative 5, and I'm going to square it. Minus 4 times what's a? 3. And c? 2. Okay. All right, everybody should practice typing that in their calculator. Okay, give people another few seconds to type in. All right, what are you getting? 1. Okay, so is 1 positive or negative? Positive, so it can't be complex. Complex means imaginary, okay? And it can't be 1 root. You only get 1 root when you get 0, okay? So it's either got to be irrational or rational. All right, take the square root of 1. Take the square root of 1. Take the square root of 1. Is this rational or irrational? That's rational, okay? So this one is B, okay? 2 rational roots, okay? 2 rational roots. All right, we're going to do the same thing on this next one. We're going to do b squared minus 4ac. So what is my b? 9. All right, somebody who hasn't answered today, what is a? 1. Good. A is 1 and c is 3. Okay. All right, 9 squared minus 4 times 1 times 3. All right, get 69. All right, is that positive or negative? Positive, so it can't be the complex one. Complex is your imaginary ones, okay? We're not popping out any eyes. All right, it's not 1. The only time you get 1 is if you get 0. And then if you try the square root of 69, square root 69, is that a rational or irrational number? Irrational. Okay. All right, on the next one, what is my b value? 4. -4. You can make it positive because it's going to end up being a positive. All right, what's my a? 8. And my c? 1. Okay, don't say the answer yet. Give people a minute. Type it in. All right, what are you getting for that one? What is it? -16. Anytime you get a negative, remember, think about it being underneath the square root, you would pop out a I. So that would make it C, complex roots. So that's the same thing as being imaginary. Okay? All right, and number 4, I'm going to do b squared minus 4ac again. What's my b? -40. You got to square that. -4. What's my a? 4 and 100. Okay, give people a minute. Don't shout it out yet. All right, what are you getting for that one? 0. Anytime you get 0, there's only going to be one answer. There's only going to be one answer because if you plus 0 and minus 0, you get the same thing. Okay? Questions? All right, a few more. Number 2, if the quadratic equation 2x squared minus bx equals 8 has 2 real solutions, which of these describe the possible values of b? Okay, so it's talking about the solutions being real solutions, okay? So we're going to use the discriminant to help us figure this out. What's the first thing I need to do to this equation before I start any work? Move the 8 over. Very good. I need to move the 8. So I'm going to write 2x squared minus bx plus 8 or minus 8? Minus 8. Write that down, please. 2x squared minus bx minus 8. So you move the 8 first. Okay? Okay, now we're going to do the discriminant, b squared minus 4ac. Do I know what b is? Yes. Okay, so we haven't done a question like this before, so let me explain a little bit. We have to figure out what b is, so we really don't know what it is. We're going to leave it as b. Okay, we're going to leave it as b. Now, if that b wasn't there, you're right. There would be a 1 there, but there is a b, so we're going to leave it there. Minus 4 times, do I know what a is? 2, and what is c? Of 8. Okay. All right, 2 real solutions means they're not imaginary, and there's 2 of them. This has to be bigger than 0 to fit that scenario. So 2 real solutions means they're not imaginary. If they were imaginary, the discriminant would be less than 0. So it's got to be greater than 0. It can't be equal to 0 because then there would only be one solution. Okay? All right, so let's solve this. What's -4 times 2 times -8? Okay, so I'm going to drop down b squared. I'm dropping down b squared. They're saying this is positive 64 greater than 0. So this times this gave you positive 64. Yeah? Okay. Anytime you plug any number into here, what happens when you square something? Is it always going to be positive, negative, or either? It's always going to be positive. And if you add 64, will it still be positive? Yes. So that will be greater than 0. B can be any number, and it's going to work. You can pick any number. Even if you plug in a negative, when you square it, it's going to become positive. Okay? All right. That one, this is an honors type question, so I know that may be difficult to understand, but I wanted to show it to you. Okay? All right, number 3, which of these quadratic equations has non-real solutions? What's another way of saying if it's not real, it has to be imaginary? Complex, yes. Okay, so it has to be imaginary. Another word they use sometimes is complex. So we're looking for an answer choice that is imaginary or complex. Okay. So go back here and look at your chart. So in my chart, for it to have 2 imaginary, what does the discriminant have to be? Negative. Okay, so look at your chart. So to have 2 imaginary, the discriminant needs to be negative. So let's start with answer A. Start with answer A. What do I have to do first? Add 4. So it's negative 3x squared minus 13x plus 4. And I'm just going to do the discriminant. Okay, I'm going to do b squared minus 4ac. So what would go in for b? Negative 13. And for a, negative 3. And c, 4. Okay? All right, so type that in your calculator. What are you getting? 217. Can somebody else agree with that?
Yeah.
All right. Is that positive or negative?
Positive.
That's positive, so that's not the answer. Okay, so we're looking for one that has imaginary solutions, which means we need to get a negative discriminant. Okay? All right. On B, what's the first thing I need to do? Move the 4. 3x squared minus 6x plus 4. Okay. All right, so I would do b squared minus 4ac. And some of y'all can do it without writing it down. You can just type it in your calculator. For b, I'd plug in negative 6. So type in your calculator, negative 6 squared minus 4 times what? 3 times, positive 4, because remember we had to move it. Shh. What does that give you? Negative? Okay, so is that our answer? Tell me again what you got. Negative what? 12. Okay, so that's our answer. So if you get a negative, it's going to have imaginary solutions. Okay? All right, last one. What values of A result in the equation ax squared minus 12x minus 3 equals 6 having complex solutions? Okay? All right, what's another word for complex? Yep. Imaginary, and that means it's going to have a negative discriminant. Okay. Okay, look at this equation. Ax squared minus 12x minus 3 equals 6. Anybody have an idea on what we need to do first? Move the 6. Now this one, I don't think we've done one like before. If I move the 6 is positive, it becomes negative. There's something already over there in its spot. What's over there? Negative 3. What do you think we should do with negative 3 and negative 6? Not multiply, add. Combine them together, okay? Add them together. So I'm going to drop this down. So I have ax squared minus 12x minus 9. Okay, that's my equation. Ax squared minus 12x minus 9. Okay. Okay, so remember, we want a negative discriminant Remember the formula for discriminant is b squared minus 4ac. What is our b value on this one? Okay, so negative 12 squared minus 4. Do I know what a is? So I'll put an a because they wrote an a. What's my c? Okay, and I need this to be less than 0. What does less than 0 mean it has to be? Negative. Okay, so it's got to be less than 0. All right, what's negative 12 squared? 144. What's negative 4 times negative 9?
36.
Good. And you put an a with it, less than 0. All right, we have to solve that for a. What number do you think we're going to move to the other side?
144.
Okay, how do you move 144 to the other side? Subtract it. So those cancel out. So I'm left with 36a is less than, what's 0 minus 144? Negative 144. All right. And somebody who hasn't answered today, what are you going to do last? Divide by 36. Okay. What, negative 144 divided by 36? Negative 4. So what is the answer? B. Okay. Answer is B. Okay.